This is my second video about using the PSOC development kit. I've wired an analog pot into an analog input, into a pin, and I'm going to control the speed of the flashing LED using the pot. And this time I'm going to create a project from scratch. So, new project and empty PSOC 4 design. So down the bottom you set the name, call it analog LED, set the location, my documents PSOC. Also you got to make sure you got the right board type selected, and also change the application type to bootable, because we're using the nice cheap $4 version of the PSOC kit. Get rid of advanced so that you can close the, make sure you got the right board. Get rid of advanced so you can close the window with OK, and you're good to go. There's your blank project. So I guess the first thing we'll do is we'll grab our analog to digital converter. Now it's a multi-channel converter. By default you can see there's 4 channels, all differential inputs as the default. So I'm going to change that to a single channel, single-ended. And I'm going to change the name to ADC because it has this great big long name I don't want to have to reference all the time. Change it down to 1 channel. Can't go lower than 1 channel. And there's the channels at the bottom, and I'm going to change the channel to 0 to be single-ended. And the only other thing I have to change is, in general, I changed the VSS is the ground voltage, but you have to change the VREF. I changed it to VDD, and everything else I leave the same. It's a signed value that comes in. It gives you a value from roughly 0 to 2048. Okay, so the next thing I'm going to do is add the analog input pin. So pins, analog, and I'll wire that. Change the name. First you got to open it up. Make sure you've got it's analog. And I'm going to change the name to, I don't know, pot, something like that. Yeah, from the potentiometer. And then wire it to the analog input. Okay, that's done. Now I need a digital output pin for my LED. And I'll name it LED. The other thing you got to do with that, as you see in the Cypress videos, you need to just uncheck the hardware connection, because it's going to be driven from software, and it's called LED. I changed it to LED. Okay, well, let's try building it. The build will fail because I need to add the bootable bootloader object, because I specified the project to be a bootloadable project type. So you go to System and add the correct module, bootloadable. There it is. And the thing you have to configure in that is you have to point it at the hex file, the actual executable file for the project. So in that you got to go find the project. It's under PSOC and it's called Analog LED, I think I called it, and not the bootloader one, but yes, the bootloader one. Okay, I gotta fix that narration. Okay, now that I fixed that, it'll successfully build. Hopefully. It's building. There we go. Looking good. There's my APIs on the left. One thing I forgot, oh, there we go. Build succeeded. Now let's go write the code. Okay, so what I'm going to do is I'm going to do the overhead that I need to do for the A to D controller, analog to digital converter, I mean. And first thing you got to do is you have to start the overall subsystem, then you have to start the conversion. And I'm going to let mine run in free running mode as opposed to start, wait till it's done and get result. I'm just going to free run it asynchronously. So there you go, start and start convert. That's what you got to put in your initialization. And then in your loop down below, we'll just simply get the value. So here's where we'll get the value. Oh, right, we're going to need a variable to hold the converted value, because I want to limit check it and limit it to the valid range of 1 to 2047 roughly. I don't want it to go as low as 0 because I'm going to use it for a time delay value. Okay, so let's get it. ADC, yeah, get result 16. You have to specify the channel as a parameter, as an argument. And then we will what are we going to do next? Oh, I think we're going to toggle the LED next, yeah. So we're going to get the current value and set the value to be the inverse of that. So we're going to write the inverse of the read. So that essentially toggles the LED. And now we have to delay based on the analog value. So it's CY delay, and you specify milliseconds. So the analog value will be 1 to 2047 milliseconds. So that's roughly a 1 to a 2 second delay. Not a 1 second delay, 1 millisecond to 2 second delay. So yeah. Okay, here's where I'm going to limit check the analog value. Limit it to 1 to 2047. Okay. Let's give it a try. Okay, and the last thing we got to do is map our pins. So the two pins I'm using are pin 0.7 for the pot and 0.6 for the let's see, what is it? It's 1.6 for the LED. 0.7 for the pot, 1.6 for the LED. So you drag it to the appropriate pin. And build. And we're ready to, well, not quite yet. Let it finish, Mark. Ready to download. as you know, you got to get the board ready to download, so you got to unplug and first thing I'm going to select the file. So this is where you got to go into your project and pick the analog LED. This is my project file, so there it is, and that's the file I want to download. And now I got to get the board ready, so I got to unplug the board, hold down the button and plug it back in, and select the COM port, and we're ready to download. Go for it. And then test it. Turn the pot, see if the LED flashes. Uh-oh, doesn't work. There is a problem somewhere. Okay, let's troubleshoot it. This is a typical situation. The input that I used was the push button input, and that's not what I wired the pot to. So instead of 0.7, it should be 0.6 for the pot. So I had the wrong pin. Well, let's build it again. It's nice and quick when you just rewrote your pins, because it doesn't have to build your code again and such. Okay, build succeeded. Let's try it again. So we'll download the file. Oh, and we test it. Still doesn't work. Well, let's check it out and see what's wrong. I had the wrong file selected in download. For some reason it went back to the original project I did yesterday on the example. So anyway, let's select the right file this time. And get the board ready to download. And fire away. Let's hope we get it right this time. Yeah, it works. The only thing is the speed is wrong. It's, the 1 millisecond delay at the one end of the pot is just too fast, and the 2-second delay per flash is too slow. So I'm going to scale my analog input. A little more difficult than Arduino. Arduino gives you the map function, I think it's called. But anyway, so I'll do a little y equals mx plus b, and I will just take the analog value, divide it by 2. I don't need to go all the way to 2000. This will take me to 1000. And then add a 100 millisecond lower limit. So divide by 2 and add 100. And that'll give me a better range for my analog. That built fast. Now download it. Got the right file this time. Downloading, and this time it works much better. There we go. So that's the minimum rate and the maximum rate. Much more reasonable speeds. So there you go. $4 microcontroller based flashing LED.